Let's go ahead and practice the disk method. In this problem, we're being asked to take the region bounded by f of x equals e to the x plus 2, y equals 7, and the y-axis, and we want to revolve that region about or around y equals 7. To do this, we'll approach it like any other problem where we'll sketch the region that we're interested in. So I go ahead and mark our y-axis, x equals 0, our line y equals 7, as well as our exponential that has just been shifted up by 2, right? So we have our typical exponential e to the x shape. All we've done is we've shifted up 2. So add 0, e to the 0 would be 1 plus 2. We start at a height of 3. So the region we're interested in is shaded right here in blue. And our goal is to rotate that region about the line y equals 7. To help me visualize the region that's being produced, what I like to do is I like to draw the clone of what would have been produced up top with a little dash line. So here, this graph, it's almost just a reflection. I go straight up, and then this arched curve would go like that. Then what I like to do is draw a piece of the revolution. So here, I'll just grab one little slice, and I'll imagine if I rotated it around that, so I twisted it all the way through across this line, it would create a circle or a disk of this shape. And then the logic would be if I took these shapes, right, these disks, and I did a bunch of these across the way from x equals 0 up to whatever this intersection point, we gotta find that. If I did a bunch of those stack, and I found each of those disks, if you just add up all of the disks across horizontally, we would then be able to produce the volume of the entire thing, okay? Therefore, setting up our integral, we get the volume is equal to the integral of pi r squared, because we're working with a disk or a circle here. The radius is going to be what? Well, looking right here, what is this length? Well, it would be the entire height of this, which would be up to 7, so this is a height of 7, minus the height that it would take to reach right here, which would just be the height of the function e to the x plus 2. Therefore, our radius would be 7 minus e to the x plus 2. And as we discussed, we're going to go ahead and be stacking or accumulating these disks horizontally from left to right. Therefore, our integral is going to be with respect to x. Now the question becomes, well, what about my bounds? I do know that my bottom bound is going to be 0 because I'm starting at x equals 0. I'm starting on the y-axis and I'm moving across. And to get our top bound, we have to find the intersection point right here between the functions e to the x plus 2 and 7. To do that, we simply set these equal to each other and solve. We end up getting x equals ln of 5, so we'll put that on our top bound here, and there you have it. The volume of our bounded region would be equal to the integral from 0 up to ln of 5 of pi times 7 minus e to the x plus 2, all of that squared, dx. I won't solve this all the way through, but if you do, let me know in the comments down below what you get.